Welcome to this explainer. Okay, let's be honest. If you're returning to study, or really even if you're just trying to wrap your head around a new technical concept, you've probably hit that exact moment of dread. You turn the page and boom, there it is, an equation. It's this seemingly impossible, intimidating wall of Greek letters, numbers, and just strange squiggles. It can trigger a massive psychological block, right? But hey, I want you to take a deep breath. Today, I'm promising you a completely new way to see those symbols. We're going to literally dismantle that wall, brick by brick. So what if I told you an equation is actually just a story? No, seriously, they aren't these mysterious, convoluted math problems designed just to trip you up. They're simply sentences waiting to be read. Okay, let's dive into this. We're going to look at equations through a language acquisition model. Here's our roadmap to tackle this piece by piece. We'll cover reading equations without fear, the mathematical building blocks, why units matter, decoding mathematical stories, and finally, models, not reality. All right, starting with number 1, reading equations without fear. It's time to overcome that psychological block. The big secret here is that experienced engineers and scientists, they don't read equations all at once. Think about it. If you look at a whole paragraph of a foreign language you don't speak, you're going to be completely overwhelmed. But if you break it down, word by word, piece by piece, it starts to make sense. Our source material gives us this brilliant quote, "They are sentences written in the language of mathematics." I absolutely love this perspective. Equations are really just highly compact, super efficient ways of expressing ideas. They're telling you stories about how the universe works, just written in a different alphabet. Let's consider one of the absolute most famous equations in physics. F equals ma. It's just 3 letters. But this isn't just a math problem. It's a story told by Sir Isaac Newton. It tells us that force causes acceleration. It tells us that a larger force produces a larger acceleration. And if you have a heavier object, meaning a larger m for mass, well, it requires significantly more force to achieve that exact same acceleration. In just 3 symbols, Newton managed to describe the motion of the universe. Pretty wild, right? Moving on to part 2, the mathematical building blocks. This is where we meet our variables and constants. Look, if we're going to read sentences, we absolutely need an alphabet. And our mathematical alphabet is basically broken into 2 main categories, variables and constants. Variables are exactly what they sound like, things that can vary or change. Constants, on the other hand, are the exact opposite. They're fixed. They stay exactly the same no matter what. So if you have an equation like velocity equals distance divided by time, well, the distance and the time can change depending on your road trick, right? Those are variables. But constants give us our stability. They are the known facts. Let's run through some examples. Take a look at this quick vocabulary list of common variables. We've got position as x, velocity as v, time as t, mass as m, and temperature as a capital T. Now, when you see these letters in an equation, please don't let them be obstacles. They're simply placeholder labels for numbers that might change. That's literally it, just a label. Now, let's contrast those with our constants. We have c for the speed of light, g for Earth's gravitational constant, and of course, our old friend pi. These are the majestic, fixed quantities of our universe. They anchor our mathematical sentences and give them a solid, unwavering foundation to stand on. Okay, part 3, why units matter. This is all about checking your work. If variables and constants are our alphabet, units are the grammar. And frankly, the most important part of an equation is often not the numbers at all. It's the units. Take a velocity of 10 meters per second. Where did that even come from? Well, a distance of 100 meters divided by a time of 10 seconds. 100 divided by 10 is 10. But listen to the actual words. Meters divided by seconds equals meters per second. The units literally tell you the meaning of the equation. This makes units an engineer's absolute best friend. So, why do we care so much? Because units help you instantly check your work. Does this answer make sense? Did I make a mistake? Am I trying to add seconds to kilograms? Think about this. In 1999, NASA lost a $125 million Mars climate orbiter for one incredibly simple reason. One engineering team used metric units and another used imperial units. No way, right? The spacecraft literally burned up in the Martian atmosphere. Massive engineering failures throughout history usually aren't caused by incredibly complex, high-level math. They are caused by simple unit mix-ups. Checking your units is exactly how you proofread your mathematical sentence. Let's head into part 4, decoding mathematical stories. It's time to interpret the meaning. Now for the really fun part. We're going to completely shift our mindset from how do I solve this to what is this trying to tell me? Let's translate some full sentences. Take E equals mc squared. Translating this tells us that mass actually contains energy. And because c, the speed of light, is such a massive constant, a very small amount of mass equals an absolutely enormous amount of energy. Or consider P equals IV. Power increases with voltage, and power increases with current. And this brilliantly illustrates how every single equation narrates a specific, real-world relationship between physical quantities. Okay, brace yourself for this one. F equals big G, big M, little m, all divided by r squared. When you first see this in a textbook, your brain probably registers it as that intimidating wall of symbols. It definitely looks complicated. But remember our new approach. We're not going to fear this. We're going to break it down into something we can easily translate. We're going to tackle this using 3 easy steps. Step 1, identify the variables. We have F for gravitational force, big M for the mass of the Earth, little m for the mass of a satellite, and r for the distance between them. Easy enough, right? Step 2, look for relationships. Everything on top of the fraction means a direct relationship, so larger masses equal larger forces. The r is on the bottom, meaning an inverse relationship. Greater distance equals a much smaller force. And then step 3 is where the magic happens. Interpret physically. When we physically interpret that intimidating wall of symbols, what's the story it's telling us? Well, it's the story of why satellites stay in orbit around our planet. It's the reason astronauts experience weightlessness as they get further from Earth. It's the exact reason the moon orbits the Earth. Suddenly, that big, scary fraction is actually a beautiful, elegant story about gravity in our solar system. And guess what? You just decoded it. Which brings us to our final section, number 5, models, not reality. These are tools for thinking. To fully master this new language, we really need to break a persistent myth, the idea of the human calculator engineer who has like thousands of formulas memorized in their head. Let's be real, successful engineers do not memorize every equation. What do they actually do? They look up equations. They reference textbooks, they use software like MATLAB and Python, and increasingly they're using AI tools. Knowing the equation by heart simply isn't the superpower here. The actual superpower is understanding over memorization. Trying to memorize every formula is just a losing game. Understanding means knowing what the variables mean, what assumptions the equation is making, checking if the physical reasoning makes sense, and for sure, verifying those units. Think of an equation like a simplified map of a city. A map isn't the physical city itself, right? It's a model that helps you navigate reality. We don't worship equations, we just use them as incredibly handy tools for thinking. So, moving forward, here's your summary toolkit. When you see a new equation, you don't need to understand the whole thing immediately. Just stop and ask yourself these 4 simple questions. What are the variables? What are the constants? What are the units? And what physical relationships are being described? If you do this, you completely strip the fear away. I want to leave you with this final, incredibly powerful rally cry from our source material. Do not fear equations. Read them. Listen to the story they're trying to tell. The universe is quite literally speaking to us through mathematics. Once you realize these are just sentences expressing relationships about the physical world, that intimidating wall of symbols simply vanishes. So, I'll leave you with this question. What story will you decode next? The next time you open a textbook or read a technical paper, don't skip over the math. Lean in, find the variables, check the units, and just read the sentence. You now have the language skills to do it. Thanks so much for joining me on this explainer, and happy decoding.